Okay, welcome to the first video lecture for Computer Science 161. Today we're going to start by looking at a simple basic Java program. We're going to make observations about it and ultimately decompose it into 4 parts: comments, classes, methods, and string literals and printing. So we'll talk about each of those 4 parts in more detail. And then at the end, we'll talk briefly about escape sequences and concatenation, and that has to do with printing, so it kind of goes along. Okay, so here's our very first example of a Java program, and I want you to do 2 things. The first is pause the video and copy this code down in its entirety into your notebook so you can take notes on it. And then the second thing is, after you copy it down, you should spend maybe 1 to 3 minutes and make observations about this code. Okay, so what do you notice? What sort of patterns do you see? What sort of repetition do you see? If you've done the reading, you can probably pull out a lot of meaning from this code, but I claim even if you haven't done the reading, just by making simple observations, you can start kind of pulling it apart and understanding what this code does. Okay, so pause the video, copy it down, make observations, and then come back. Okay, so for me, looking at this code, I think the first thing that jumps out to me is I feel like there's 2 different sections going on here. Okay, so at the top, there's this part, which seems to be different than this part down here. And that's because I feel like the top part has a lot of repeated symbols, like the asterisk and the @ sign, which doesn't occur down below. And so they seem to be kind of 2 different things. Indeed, they are. This top part is a comment, and it's a specific type of comment known as a Java doc comment. And down below, we have what's known as a Java class. So we'll talk about each of these in more depth, but a quick summary: comments are ignored by the computer, and they're for the purpose of providing information to other human beings who are reading the code. Okay, so that's why this comment's at the top, and it has a sentence describing kind of the overall purpose of the code. And then we have 2 tags here, @author and @version. The @author tag is how you will put your name on your assignments, and the @version tag is how you put the date on your assignments. So that top part is a Java.comment, and then down below we have what's known as a Java class. And a class, for now, we're going to think of a class as a container. It's something that contains our code, and it has a name, public class hello world. That's a name that I gave to the class. And then we have an open curly bracket and a closing curly bracket. And all of the code between that opening and closing curly bracket is contained within the class. Oftentimes, you'll hear people use the word scope. So the open and closing curly brackets denote the scope of the class, okay? When we look inside the class, at least for me, I feel like when I look inside the class, I see another unit, like another self-contained chunk, okay? So here, and this is known as a method. Again, methods have also their own curly brackets. So we have an open curly bracket again, paired with this closing curly bracket. Oh, I got this one. And again, everything between the opening and closing curly bracket is contained inside the method. Okay, so again, the opening and closing curly bracket denote the scope of the method. This method is not just any method, it's a pretty special method. called the main method. And the main method is where the computer starts executing your code. Okay, so it's an entry point into your code. Basically, when the computer runs your code, it's going to scan looking for the main method. And then when it finds it, it will execute all the code inside the main method from the top sequentially down to the bottom. Okay. In fact, if you did not have a main method, then the computer would throw an error, and the error would basically be, I don't know where the main method is, so I don't know where to start. Okay, so this isn't just any method, it's a pretty special method. Almost all the code that you write will have a main method. Okay, so we have a java.comment, and then we have a class. Looking inside the class, we have a method, and then looking inside the method, this first line is another comment. Okay, this is called an inline comment. I called that because it is in line with your code. And then we have this, which is a print statement. Interestingly enough, although this file, print statement, although this file has a lot of lines in it and has a lot of code, the only line of code that does something, at least from the perspective of the person running your code, the only line of code that actually does something is right here. Okay. So although there's a lot of lines of code here, really only one of them has an effect that the user can see. Okay. Okay, so that's kind of the breakdown of code from comment to class, class to method, method to print statement. I want to quickly take this code and put it into BlueJ so we can see, what does it do. So I have here a class that I've already written called Hello World, and it has that code in it. So you would hit compile, right? Class compiled, no syntax error, so that looks good. And then to run code, you can right click, choose the main method, hit OK, and there we go. Okay, so the purpose of this code is it pops up a console and then it prints hello world to the console. Okay. Okay, so what we're going to do is spend the rest of this video looking in depth at these four things: comments, classes, methods, and print statements. And we're going to begin by talking about comments. I've already mentioned that comments are ignored by the computer. And the purpose of a comment then is to provide non-obvious information about the code. Information, oh man, about the code. So you're going to be writing a lot of comments this semester, and oftentimes, particularly when you're beginning, it's not clear what comment should I write. And a good rule of thumb is to ask yourself, is this comment already obvious? Okay, so for example, in our Java program, I called the class Hello World. Okay, so you don't really need a comment saying this class is called Hello World, because you look at it, it's pretty obvious and it doesn't need explanation. As the semester goes on and the code you write becomes more complex, oftentimes you'll add comments to help whoever's reading your code, which may be someone else, or maybe you, days or weeks down the road, to provide them with information that is not immediately apparent. Okay, so things like, what is this chunk of code doing? Why are you doing it this way? For me, I know personally when I program, I tend to program over a series of months. So, after 6 months, I look back at my original code and I don't remember what I was thinking. So oftentimes I'll write comments to myself like, here's where you got this equation from, here's what it means, here's why you set the constants, don't change this, you're gonna wanna change it, but you read about it and it's correct, and just leave it alone, okay? Oftentimes I think people believe that comments are not important because they're ignored by the computer. So you can run your code, you can write and run code and have absolutely no comments. And from the computer's perspective, it doesn't really matter. Okay, so there's a tendency to believe that comments are not as important as the rest of your code. However, I think historically looking at computer science and looking at, different software projects that went wrong, sometimes horribly wrong, sometimes, lives were lost wrong. One of the things that stands out is bad code tends to be code that isn't commented. Okay, so even though it's ignored by the computer, comments tend to be, I would say, one of the most valuable parts of your code, even unto, life and death valuable parts of your code. Okay, so you're going to be writing a lot of comments this semester, so you'll get plenty of practice. And thankfully, none of the code you write is there's no lives on the line, so that's good. Okay, in Java there are 3 types of comments, and we've already seen 2 of the 3. So the first is a Java doc comment, and Java doc comments begin with an open, /***, and then you can write whatever you want, */*. Okay, so when the computer sees the /***, it scans until it hits the */*, and that's how it knows where the comment begins and ends, and it ignores it. Inside a Java comment, as we've seen, you can have tags. So @author followed by your name, and @version followed by the date. Anytime you write code in this class, whether it's for a lab assignment or a homework assignment, you should always have at the top a Java doc comment with a sentence describing the purpose of the code, and then @author and your name, @version and the date. And that's how you'll put your name and the date on your code. Okay, the second type of comment is an inline comment. And an inline comment begins with 2 //. When the computer sees the 2 //, it ignores everything that comes after. Inline comments, I think for me, the way I differentiate them is inline comments, because they're inline, tend to provide specific information about specific lines of code. Okay, so I would say inline comments kind of communicate low-level details about particular lines of code, whereas Java doc comments tend to provide high-level information about the entire file. Okay, so it's kind of a little bit of a difference between the 2. And then lastly, we have what are known as block comments. Block comments begin with a /**, and then you can write whatever you want, and they end with an */*. Block comments and Java doc comments look almost identical. The only difference is the second asterisk here. And this is for historical reasons. So block comments originated in a different programming language. And in fact, block comments really spread. They're quite general. So if you're writing code in C or C++, block comments are something that you can use. So when Java was created, the creators of Java wanted to create a different type of comment, a Java doc comment, but instead of creating something entirely new, they decided to leverage people's familiarity with block comments by just adding a second asterisk, okay? The difference between them, again, is the block comment is not Java specific. It actually appears in lots of different programming languages. The Java doc comment is Java specific. And then the Java doc comment, you can use these tags, the @author and @version tags. Although you can put those tags in a block comment, they won't have the same functionality, okay? And we'll see in a few weeks, the @author and @version, they do something more than just, put your name on your homework assignment. They actually have a purpose, and we'll see what that purpose is in a few weeks' time, okay? So just to recap, I would say Java doc and block comments are for providing high-level information about your code, whereas inline comments are really more for low-level details. And then for details, block comments and Java doc comments, they really just differ, right, in terms of that particular asterisk thing. Okay. Okay, so looking at classes, I've already given you a definition for a class. As the semester goes on, we'll look at classes in more detail, and we'll kind of develop a deeper philosophical understanding of what a class is. For now, though, we're just going to go with the definition, which is a class is a container. For code. As such, all code must be contained within a class. Ooh, that doesn't, nope, must. So all code must be contained within a class. Classes start with public class, and then you'll give your class a name, open curly bracket and closing curly bracket. You cannot have code above the public class. You cannot have code below the closing curly bracket. All code has to be contained within the open and closing curly brackets for the class. Also, in terms of naming your class, the name is up to you. However, the class name should be 1, uppercased, and it should be relevant. There are other requirements for the name of a class, and the book talks about that in the reading. I want to focus on these two. So the name of your class should be uppercased. The computer does not care if you uppercase the name of your class. However, it is a very strong human convention that it should always be uppercased. The reason why is in Java, anytime you see a word that is uppercased, you know it is a class. So classes and only classes are uppercased, and that's a very, very strong convention that we're going to follow. Secondly, the name of your class should be relevant, and what I mean by that is at some point in the semester, you're going to be programming at 2 a.m. and it's going to be really funny to name your class something ridiculous like Frodo. Every semester, I feel like I have at least one Frodo. While that is funny at 2 a.m., once you go to sleep and you wake up refreshed, it's really not that funny. Okay, so try to resist the temptation to just name your class something completely ridiculous, right? It should pertain to whatever the purpose of the code is. Okay, so like hello world. Okay. Moving on to methods, so kind of looking back at our code example here, right? So we have the Java doc comment, which we've talked about, then we have the class, and then looking inside the class, we have this particular method known as the main method, and then we have the print statement. Okay, so let's talk a little bit about main methods and print statements. So I'm going to start by giving you a definition for what a method is. Then we'll talk more about the main method. And again, as the semester goes on, we're going to revisit this topic of methods and look at it a little bit more in depth. Okay, so we'll start with just kind of a high-level overview, and then it'll get deeper from there as the semester goes on. Okay, so here's our definition for a method. So a method is a series of programming statements that And we have two requirements, one, that have been grouped together, and given a name. So if you look back at the main method that we wrote, it contained a series of programming statements, really like one statement, the print statement, but still. Those statements have been grouped together using the curly brackets. So the purpose of the curly brackets is to group everything that is inside the method together. And then we gave the method a name. In this case, it was called main. When you write your own methods, you can call them whatever you want. Again, it should be relevant. Okay. It is not really apparent from this definition, but this part is super important. So naming something is very powerful. And in this context, once you give a method a name, that means that anyone can use that name to execute the method, which maybe is obvious to you, but it's actually pretty great. Okay, so if we had a main method and it had 100 lines of code in it, as soon as we give it a name, someone can say, hey, run the method called whatever we called it, main, and the computer will execute all 100 statements. And so the person calling the main method doesn't have to explicitly describe all of those 100 print statements, right? Just by referring to the name, you are referring to all of those 100 statements, okay? So a method is a series of programming statements that have been grouped together and they've been given a name. Now the main method, as I said, is a very specific, important method. Public static void main. Okay. String bracket args. Args is short for arguments. So this is the name of the method here. Methods, we'll see a little bit later why always have parentheses. And then this is the open curly bracket and the closed curly bracket. As for these other words, public static void, string args, although we will not talk about them now, as the semester goes on, we will talk about each of those terms so that at some point in the semester, you'll stop and realize, you'll have an epiphany like, wow, I actually understand that entire line of code. Okay, so for now, you'll just memorize it. You're going to be typing this out so often, it'll become second nature. And then as the semester goes on, we'll kind of break it down piece by piece. Really, the only important thing to remember about the main method is the entry point into your code. The entry point for your code. Now, BlueJ, if you were to write the main method, but let's say that you accidentally had a typo and instead of calling it main, you called it main. Okay, so you had M-A-I-N. So you had a typo. In BlueJ, it doesn't matter. BlueJ is meant for beginners. You can still select using the mouse the method, even if it's misspelled, and you can run it. But beyond BlueJ, when you write a Java application, if you were to misspell this method and you would go to run it, in fact, that's when you would trigger an error and the computer would say, you don't have a main method. I don't know where you want me to start. Okay, so oftentimes people will either misspell main or they'll forget, maybe they'll drop the static, drop the void. And BlueJ is very forgiving, but in reality, each of these pieces has to be exact. Public static void main, string args, so on and so forth. And that's how the computer knows where it should begin executing your code. Okay, last but not least, I want to talk about string literals and printing. When we looked inside the main method, really the only statement that did anything from the user's perspective was that print statement. Okay, so let's talk about what was going on there. So we're going to begin by talking about a string literal. And a string literal can be defined as a string literal is any sequence of characters between double quotes. So we've already seen an example of a string literal, which was in our program, I had double quotes and inside it said hello world. Here are other examples of string literals. So Bob, that is a string literal. It's a sequence of characters between double quotes. This is a string literal, open double quote, close double quote with nothing inside. Okay, this is a string literal. It's known as the empty string. Okay, so it's empty. There's nothing in there. It's just two quotes. That is not to be confused with this string literal, which is open double quotes, space, closing double quotes. So this is a string literal that has one character that we can't see. It's a space. This is also a string literal, 4.2. Not to be confused with the number 4.2. This is the string literal 4.2. In computer science, as we'll see, the type of an object is very important. Whereas in mathematics, we often don't think of the type of something. In computer science, it's absolutely crucial. So there's the string literal 4.2, and then there's the number 4.2. The number 4.2 can be added to, subtracted from, multiplied, divided, whatever. The string literal 4.2, it would be odd to try to, for example, divide it by 2. Like, what does it mean to take a string and divide it by 2? It's not even clear. So although, you know, the string literal contains the characters 4.2 and the number 4.2, although they look the same to a human, their types are different. Thus, to the computer, they are completely different objects. One is a number, one is a string literal. Okay, and that determines what I can do to each object. Okay, so this is the string 4.2, which is different from the number 4.2. Okay, what can you do with string literals? At this point, really all we know is you can print them. Okay, there's two ways to print a string literal. The first is what we saw, which is system.out.print ln. Or you can call system.out.print no ln. Both of these take as input between the parentheses a string literal, okay, whatever it is that you want to print to the screen. Okay, so they have the same input, but the difference between them, I'm getting a little ahead of myself. The difference between them is that print ln, that ln there is actually quite important. Print ln will print the string literal you pass to it, and then it will advance the cursor to the next line. So ln stands for line. So that the next time you print, it's going to pick up on the next line, where system.out.print will print the string literal you pass to it, and then the cursor will remain there, so that the next time you print, it's going to pick up right where you left off. Okay, so system.out.print ln versus system.out.print. There was something else. Oh, okay. I want to make a few observations about this line, system.out.println. And if you don't understand these observations, go ahead and disregard it. If all that you understand is that system.out.println, that's how I display things, that's perfect. Okay, but I wanna take what we've learned in the past 20 minutes and show you, even with this basic information, you can actually start making some pretty sophisticated observations. For example, system is capitalized, okay? And we just said that the only things in Java that are capitalized are classes. So indeed, right, system is a class. Okay, somewhere on your computer, unbeknownst to you, is a file called system.java. And if you open it up, you'll see that inside it says public class system. Okay, so this is a class written by somebody else, and it's pretty cool that we get to use it to do things like printing to the screen. Later in the semester, we'll talk about what these dots are and what this out is. But println, notice that it has parentheses. This is in fact a method. So if you were to look inside the system class, you would see that there is a method called println, and this method was written by someone else. I've never even seen the method before, but the really cool thing is, as soon as that person gave a name to the method, println, we can now use that method just by calling the name. Okay, and I honestly have no idea what that code looks like, don't know how it works, don't care, right? As soon as I know what the name is, I can use the name to execute the method, and I don't need to know anything beyond that. Okay, so whatever this method does, it looks like it takes in a string literal, and then it has some code for opening a console and displaying that string literal on the console. Okay, so even in like the past 20 minutes, you've learned enough information to start making some more sophisticated and deeper observations about code, okay? Okay, that's basically it. The last thing I wanted to quickly talk about are escape sequences and concatenation. And that is because if you go back to our definition of a string literal, which is a string literal is any sequence of characters between double quotes, if you think about that long enough, one of the questions you'll have is, what if I want to put a double quote between double quotes? Okay, so sometimes I want to actually print a double quote. Okay, so for example, let's see. I have this Java class that I made called printing. And let's say that I want to print a quote by Martin Luther King Jr. to the screen, I have a dream. Okay, so maybe the most straightforward basic thing to do would to be system.out.println, right? I have a dream. Okay, so I have two sets of double quotes here. This one is opening the string literal, and then this is the actual quote itself, and then closing the string literal. Okay, and that seems pretty basic, right? Pretty straightforward. But if I compile, you'll see that I actually have 3 errors. Okay, and I'm not sure if you can see like the red squiggly lines for the 3 errors. So if we hover over that, it says a closing parentheses was expected. Okay, so if we think about this from the perspective of the computer found a print statement, looks good. Then it saw an open parentheses, looks good. Then it saw an open double quote and then a closing double quote. And so at this point, the computer thinks that this is the empty string. And the next thing it would expect is the closing parentheses and the semicolon. And instead it finds a capital I. Okay, so at that point, the computer or the compiler throws an error saying, I expected a closing parentheses, I got a capital I, I'm not really sure what's happening. Okay, so it's not as straightforward as just putting a double quote inside a double quote. That doesn't work. Okay, so that leads us to escape sequences. And an escape sequence is a sequence of 2 characters. The first character is a backslash. And when the computer comes across the backslash, it knows the next character should be interpreted differently. Okay, so I'm going to make a table of the four most common escape sequences, and then we'll look at an example. So inside a string literal, you can use a \t, and that will be interpreted as a tab. Okay, so if you wanted to insert a tab into your string literal, a \n is a new line, otherwise known as an enter or a return. So if you have a \n, it'll print the string literal. When it gets to the \n, it'll move to the next line and it will continue printing. A double quote is a \quote. And then last but not least, if you wanted a \ itself, now because of escape sequences, that's problematic. So if you want a \, you have to / your \. Okay, so 2 backslashes produces a \. So going back to our code, if we wanted, we would put a \ in front of each of these double quotes. Okay, so this double quote is opening the string literal. Then this escape sequence will print as a as a double quote. Then I have a dream, another double quote, and then we're closing the string literal. Okay, and we can compile and we see that that looks good. And maybe we want to print out, right, by Martin Luther King Jr. It's always nice to kind of indent the attribution a little bit. It looks nice. So we can hit compile, and then we can run that, and there we go. Okay, so the quotes are showing up, and then notice that Martin Luther King Jr. is indented a little bit because of the tab, right, this tab that I put right here. Okay, last but not least is concatenation. Oftentimes, and this will happen more at the end of the semester, you want to print a string literal and it's too long, in the sense that if you were to just print it, it would be really long and anyone reading your code would have to scroll just to read it. And they will not thank you for that. This seems like a really minor thing. It's like, I want to print this string literal, it's long, get over it, it's not the end of the world. However, it's not the end of the world, but for example, if you worked at a company, any software like Google, they have very specific criteria for your code, and one of them is that your code can be no longer than 80 characters. At that point, I don't want to keep scrolling, okay? So oftentimes when your string is too long, you can break it up into multiple pieces, and then you can use the concatenation operator to glue them back together. And we'll see an example of this. So in Java, the concatenation operator is the plus symbol. But there's a little bit of a problem because in Java, the plus symbol actually has two purposes. It's either used for addition, which is kind of the more typical use of the plus symbol, or it's used for our purposes, which is for concatenating. So when the computer executes code and it comes across a plus symbol, there's a little bit of ambiguity. Is the programmer asking the computer to add or to concatenate? Okay, so there's a rule that the computer uses to differentiate which of these two uses are you referring to. Okay, and that rule is if the operands are numbers, then it must be addition. But if at least one of the operands is a string, by which I mean it's a string literal, then it must mean concatenate. So let's see an example of that. I have another arithmetic. Okay, so here's some Java code that I wrote, and this illustrates the different uses of the plus operator. Here's my example of a very long string. Okay, so I could just have this as one very long string. It's not even that long. Okay, but imagine that this is a very, very, very long string, and help you imagine that there. Okay, so if you had a very long string and it's going beyond the bounds of the window, one thing you can do is you can break it up into two strings, and then you can concatenate them together with the plus symbol. When the computer executes this line of code, it's actually doing two things. So first, it recognizes that this is a call to the println method, but when it looks at the input, it sees there's not one string literal, there's two string literals. So the very first thing that it will do is it will concatenate them. It will take those two string literals and glue them together to make a single string literal, and then it will pass that string literal to the print method. Okay, so that's how concatenation would work. I also wanted to show you, so then I print out, I can do basic arithmetic. Here I have a call to system.out.println, and I'm passing in nothing. That's totally valid. This will print nothing, and it will move the cursor down to the next line. This is a great way to just get white space. So if you kind of want to organize the output or the print statements, this is kind of a nice trick. Okay, so here's three different print statements that are using the plus symbol. And here, right, we have a string plus a number. So going back to our rules, because one of the operands was a string, this means concatenation. Okay, so it's going to take the number 9, turn it into the string 9, and then glue those two strings together. So we should see 5 plus 4 equals 9. The second one down here, though, is a little bit ambiguous, right? We have two plus symbols. If the computer evaluates this first, it should be concatenation. But if the computer chooses to evaluate this plus symbol first, that would be addition. Okay, so depending upon whether or not the computer's evaluating this first or this first, we could potentially get two different things printing out. Okay, so we're gonna have to see what does that do. Here, I'm using parentheses. So just like in mathematics, we have PEMDAS, please excuse my dear Aunt Sally, which is the order of operations. So too in programming, if you want to enforce that something happens first, you can put it in parentheses. So here I'm using parentheses to say, first evaluate this plus symbol, which according to our rules is addition, because those are both numbers. Then once you have the answer, go ahead and evaluate the whole thing. Okay, so in fact, this print statement and this print statement should be identical. Okay, you should pause this video for like 5, 10, 15 seconds and predict what do you think is going to print out at this line. Okay, and I'm going to run it now so you can see if you were correct. Cool. Okay, so I'll run the main method, hit OK, and there we go. Okay, so we have 5 plus 4 equals 54. Okay. So let's maybe go back to the code and figure out why did it print out 54, like what's happening there. Okay, so from the output, we can kind of infer it must be that the computer executed this left to right. Okay, so the first plus symbol that was resolved was here. So we have a string and a number. So this is concatenation. So it takes the number 5, turns it into the string 5, and then glues those together. And the result then is this. And then it resolves this second plus symbol. Okay, and again, it has a string and a number. So that's concatenation. And in the end, we get this. Okay, so we get 5 plus 4 equals 54, which is not true. Okay, so that's, this file is just kind of showing the different uses of the plus symbol. Sometimes, as in this example, it's not always obvious what the plus symbol means, and you can use parentheses if you want to group things together to make it unambiguous. Okay, so that is that. So kind of quick recap. This was our starting code here, broke it down. It's really composed of these 4 things: comments, which you will be writing lots of this semester; classes, which you will be writing lots of this semester; methods, in particular the main method, which is really important. That's the entry point into your code. And then last but not least is printing. At this point, the only code we can write is code that prints stuff. That's all we know how to do. So you should have an understanding of what a string literal is, the difference between these 2 methods, and then escape sequences and concatenation. All right, that's that. And we're done.